recording. 4.5. Solve quadratic equations.
That on the recording.
By finding square roots. No, see, I say that because one day some kid was talking about the fact that they had 5 energy drinks that day and their parents don't let them have them at all, and they like went and bought them, and I was like, well, you better not listen to this video at home then.
Oh my god.
5?
They were like, don't tell my mom, and I was like, if they go watch my video then they would hear it. What?
Again? Bro.
Yeah, okay. See, I have a feeling.
Alright. Simplify the expression. So basically, to start out with, you're going to be given some square roots, and we're going to be breaking them down and simplifying them as much as possible. Most of them are not going to be perfect squares, so just be aware of that.
Oh, yeah.
But let's start with 4. Sophia, you don't have anybody to guess with today.
It's the
Nice,
10.
you can guess.
I thought
All right, the square root of 192.
the 10.
So this is not a perfect square. So what I do is I do a factor tree to break it down. So what are 2 things that I can multiply that equal 192? If it's an even number, we always know what's going to work. 2. So 2 times what is 192?
Great question.
96. Yeah, I was right.
96.
Yeah.
All right.
Shut
Now,
up.
2 can't break down any farther because 2 is prime. So then 96. What can that break into?
Wait.
Another
No,
2.
2.
Another 2.
Yes,
Yeah.
Wait, 12
We have
and
a
8.
variety of options here.
Wait, can 12 and 8?
240.
Or is that not right? 40. Nope, that's not right.
12 and 8.
Wow.
Wait,
Or wait.
is it 12 and 8?
Yes, 12 and 8
Oh,
would
I'm
work.
a genius.
I'm going to do that so that my tree's not so big. But yes, you could keep going down with a 2. You could go with a 3 would work. 4 would work. We have options. But this way my tree won't be so large. All right, what does 12 break into?
3 and 4.
3 and 4. 4 breaks into.
2 and 2.
And then 8 breaks into.
4 and 2.
4 and 2. 4 breaks into 2 and 2. All right, so I have all these numbers down here at the bottom that I'm working with. It's a square root, so I pull things out in groups of 2, right? If I have the square root of 36, that's 6 times 6. I'm pulling things out in a group of 2. For every 6 that or every 2 6s, I'm taking 1 out. So I'm taking out a group of 2 here, a group of 2 here, and then I have to ignore the 3. So I'm taking out 3 groups of 2s. So this is going to be 2 times 2 times 2 times the square root of what's left. The only thing that was left is a 3 times the square root of 3. So this is going to be 8 root 3. That's your answer.
8.
Two.
I had a really good weekend.
So.
You have a question? Or are you just processing?
Why is 3 in the square root?
Because there wasn't a pair for it. It
Oh,
was
so you
by
just
itself.
basically match
It was the only one left, yeah.
Oh, okay, so you pair the numbers up. Okay.
So, like, if there had only been 5 2s, then I would have been left with 2 times 3 inside. Like, instead.
Were we mock?
No, I just actually.
All right, 6. Square root of 3 times the square root of 27. So, rules of square roots. If I have 2 square roots being multiplied by each other, I can multiply what's inside of them. So, this would be the square root of 3 times 27, which is the square root of 81.
Oh, it's
Now.
9.
That is a perfect square, so I can just say that that one is 9. I don't need to do a factor tree on that one.
Yahoo.
Yeah.
Yoo-hoo.
All right. Number 8.
Go with my Lego set.
5 times the square root of 24 times 3 times the square root of 10. So on the last one, it was just 2 square roots multiplied by each other and multiplied what's inside. On this one, I'm going to multiply the stuff that's outside and the stuff that's inside.
15 and 240.
Yep, so 15 times the square root of 240. Now, is that a perfect square?
No idea.
It is
Doesn't
not.
look like it though.
So I'm going to break that down. I don't even need to write 240 up here. I can just write 24 and 10. When it's like a big number like that, you can just start breaking it down.
5 and 2.
All right, so 10 is 5 and 2. That can't go any farther. What about 24?
12 and 2. And then,
Or 6 and 4.
and then 4 and 3.
Yeah.
Like that. Okay, yeah, sure.
4 and 3.
I went with 12 and 2. That's what I heard first.
Oh. Yeah, because I said 12, 2,
And then
4,
again,
3,
2
2,
and 2.
2.
Yep. So I have a group of 2. I have another set of 2s here. And then I have a 3 and a 5 left over. So I'm taking out 1, 2, and then another 2. So I'm taking out, so it'll be 2 times 15 outside. And you don't have to like write this every time. You can like just write what that number is equal to. I'm just doing it so we can see it. And then inside, I have 3 times 5. Again, you could just write that as 15. And so then to simplify that, that ends up giving me 60 times the square root of 15.
Question, will calculators be allowed?
Nope.
Oh, no.
This isn't
It's
that
not,
bad.
no, but I make silly mistakes without calculators.
Well, practice makes perfect.
All right, 10. Square root of 35 over 36. So, this is all in here. If I can reduce this, I would do that first. But rules of square roots tell me that if I have the square root of a fraction, this would be the same thing as the square root of 35 over the square root of 36. We can never, ever, ever leave a square root on the bottom. So we'll have to do something. This one won't have it, but we'll have
It's
to do
6.
something else. Yes, the bottom is 6 of this one. Now, the top is the square root of 35. What does 35 break into?
75?
Now, do either of those break down any farther?
No.
So I can't take anything out, so this is just going to be the square root of 35 over 6. And that's all you can do with that one.
So what did you say?
12. I've got 7 over the square root of 12.
Oh, no.
Leave it.
All right, so the first thing I'm going to do is obviously see if there's anything that I can take out of my square root. And so breaking down 12, 3 and 4.
22.
So that tells me I can take out a 2, but I'm still going to have a 3 inside. So to rewrite this, this is going to be 7 over 2 root 3. This is bad. I cannot have a radical on the bottom.
So is it just insoluble?
No. So I'm going to multiply by the square root of 3 over the square root of 3. So on top, I end up with 7 root 3. Just turn that off because it's going to keep doing that. Okay. All right, so 7 square root of 3.
And then 2's on the bottom.
2 times 3 is on the bottom. The square root of 3 times the square root of 3 would be the square root of 9, which is 3. So this is 2 times 3. I'm just doing this so we can see it, which is 7 root 3 over 6. And that would be my final answer.
This looks pretty simple.
Now, this stuff of multiplying to get rid of a square root on the bottom is going to be with us for a very long time.
Oh, no.
We use it a lot when we get to trig, second semester, so just be aware of that. We rationalize a lot. That's what this is called, rationalizing the denominator, getting rid of the radical on the bottom. So just be aware of that.
My grade's gonna go A.
Little do you.
Or section.
Gonna be an academic weapon.
All right, 14.
Jack needs help.
Square root of 13 over 28.
I'm gonna have to get 2 plus.
All right, so this is going to split the square root of 13 over the square root of 28. Now, does 13 break down?
No.
No. So I know that's just going to stay there, so I'm not even going to do anything with that. Now, 28, can that break down?
7 and 4.
7 and 4,
2, 7,
2 and 2. So the bottom is going to break down into 2 root 7.
Are you okay?
All right. So at this point, can't leave it. So I got to multiply it by square root of 7 over square root of 7. So I end up with 13 and 7. Yeah.
Which is 91.
Square root of 91. Now, I should always go back and check once I've done that and see if there's anything it can break into. However, 13 and 7 are both prime numbers that can't be broken down, so I know that I won't do that. But I'm just letting you know the process of thinking through. Once you multiply something, sometimes that gives you another thing that you can take out. So sometimes you will take something out, then once you multiply them, then there's something else you can take out. So just always check that. Then over, square root of 7 and the square root of 7 is just 7. Times 2 is 14. So this is the square root of 91 over 14.
Wow.
All right, so those are the pretty basic ones.
Then we're going to introduce variable.
Please no.
No, but I am going to get into stuff like this. 1 over 5 plus the square root of 6.
Oh.
So again, my first thought is always going to be, can I take something out? Well, 6 breaks down into 2 and 3. There's nothing I can take out of that. But I still have the issue that I can't have a square root on the bottom.
Right. So you got to multiply it by the square root of 6.
So if I do that, don't write this, just watch me. Square root of 6 over the square root of 6. Then I'm going to end up with the square root of 6 over 5 square root of 6 plus 6. I still have a square root on the bottom. Okay, so we have to multiply by something called the conjugate. It should have been in your notes. Which is going to be, we change the sign here so that we produce a difference of squares on the bottom. So we're going to multiply by 5 minus the square root of 6, top and bottom. On the top, you'll just be distributing whatever it is. Obviously, in this case, just a 1, so it's just going to be equal to that. So we've got 5 minus the square root of 6 on top. On the bottom, I have 5 plus the square root of 6 times 5 minus the square root of 6. Even though there's not a variable, that should still look like a difference of squares to you. That's going to cause the square roots to cancel. So I'm going to have 5 times 5 is 25. And then I would have over here plus the square root of 6, times negative square root of 6. So those are opposite signs. So that's going to be minus, and then those two things would just be the square root of 36, which is 6, like that. Then I just end up with 5 minus the square root of 6 over 19. And that's your answer.
Oh, that's easy.
So you just have to multiply by the conjugate. You've got to force a difference of squares to happen on the bottom. 18. 3 plus the square root of 7 over 2 minus the square root of 10. So can I take anything out of the square root of 7?
Oh,
Can I take anything out of the square root of 7?
no.
No.
Can I take
Sorry.
anything out of the square root of 10?
But
But you can't
Okay,
take anything
so
out of that. So
That's what it breaks into, but I can't take anything out, so I just gotta leave it. So I'm multiplying by the conjugate of the bottom.
2 plus
Okay.
the square root of 10.
Yep, so 2 plus the square root of 10, top and bottom. Now, I gotta watch and be careful with the top now. The top isn't just a little distribute anymore. I've got to FOIL the top. Okay, so the top is going to be 3 times 2 is 6. 3 times square root of 10 is 3 root 10. Square root of 7 times 2 is 2 root 7. And then square root of 7 times the square root of 10 is the square root of 70.
That's all the square root.
So again, once I've done that, I need to look and say, is there anything I can take out of any of these? I still can't.
5 and 2.
So no.
So there's still nothing I can do. Good hint is if I couldn't take anything out of these two and there's no common numbers, I'm not going to be able to take it out of the big number. But always good to check. So that's the top. Now I've got to do the bottom. It's a difference of squares. So I've got 4 minus 10.
Just negative 6.
Yep. So my final answer is 6 plus 3 root 10 plus 2 root 7 plus the square root of 70 over negative 6. Sometimes I can take something out of the top and reduce it with the bottom. It just depends, but in this case I can't because they don't have anything in common.
Like that?
Yep.
That's
Oh wow.
Which looks pretty awful,
Yeah.
but
It looks terrible.
like I'd rather have this than this, but you gotta
Will we ever
rationalize it.
have to solve?
This
Well,
is
there's nothing you
solving.
can really solve at the moment, but I mean, if there's an X, like we are getting ready to start solving, but that's not the
No.
same thing.
Variable.
All right,
Square root
No.
of X. Square root of X.
solve the equation. Here you go, Addie.
Thanks, man.
22. S squared equals 169. So, to solve this, I take the square root of both sides. When I do that, I get two answers,
Isn't it 13?
plus or minus.
Oh.
Plus.
It's both.
Oh, my fault.
So, S equals plus or minus 13, because what's positive 13 squared?
169.
What's negative 13 squared?
169.
So there's always two answers. If you do not write both of them, you will lose points.
Okay.
That's literally all the way up through calculus. People forget that. When you're solving an equation and you're taking a square root. Now, if I just said, what's the square root of 169, what are you going to tell me?
13.
That's just 13. If I say S squared is equal to 169, you're going to tell me it's plus or minus 13. Because you're solving.
Yeah.
Because if I take either of these numbers and plug it back in for S, I'm going to get 169. Okay? But people tend to mix those up, so I'm just making sure we're going over that. 24. X squared is equal to 84.
I love it.
Now, is that a perfect square?
No.
All right, so I have X is equal to plus or minus the square root of 84. I should then see if I can break it down. So 84 breaks into what?
42.
2 and 42, sure. What else? 42 breaks into?
Isn't it 6 and 7? No, wait. It is.
It is.
Yeah. No. Well, I was like having brain fart. And then 2 and 3. So, dude, shut up. It's what the answer was.
Or you could have done 2 and 21 and avoided the whole awkward situation, but it's fine.
Well, you know.
Yeah, let's
Just
do
as long as
this
Mr.
one.
Foster doesn't
Or
work
like
with guys.
3 and 4.
All right, so I can take out a 2, and then I have a 3 and a 7 left. So this is going to be plus or minus 2 root 21.
So that's just the answer.
Yep.
Oh, wow. Dude, shut up. No.
What's the future?
You can't even
As
see
you're
a straight
laughing
face.
about it.
That was real. That was genuine.
All right,
Do that with your mouth. Crack
just
my
2
smile.
more. 28. 7r squared minus 10 equals 25. So, obviously I'm solving. That means I'm trying to get the variable by itself. So what's the first thing that I would do?
Add 10 to the other side.
Add 10. So 7r squared equals 35.
And divide by 7.
Divide by
R
7.
squared equals 5.
Look, she's such a smart little bean. Ew.
Did you call me a bean?
Now what?
Square them.
It would just be R
Square
squared
root.
equals square root R squared.
R is equal to
Yep,
the plus or
yep.
minus square root
What he
of
said. I was gonna get
There you
there
go.
eventually
I don't know.
after I get struggled.
It was seeming questionable.
It's this one.
R equals plus or minus the square root of 5.
Because 5 doesn't go anywhere.
Oh, look at you.
All right, last one, 32. 7 times x minus 4 squared minus 18 equals 10.
Okay, so you gotta foil this with the square root.
No, don't do that.
Oh,
Oh.
okay.
Absolutely not ever. Don't do that.
Okay then.
Plus 10. No, not plus 10, plus 18.
So I've got 7 times x minus 4 squared equals 28. Now what?
Divide by
Did you
7.
carry
Yes.
this?
Divide by 7. X minus 4 squared equals 4. Now what? Jonah doesn't want to try anymore.
Find the square root. So
Square
x
root
minus
them.
4 is equal to.
Already got
Yes,
it
it's
wrong.
still, this whole piece is being squared. A lot of people try to add the 4 first. You can't do that. So I got to now take the square root of both sides. Okay. So x minus 4 equals what?
2.
2.
What?
2. Positive or negative 2.
Yeah,
Plus or minus. We're solving.
Plus 4 plus.
Now, look at this. I can't add 4 to plus and minus 2 at the same time, so I'm going to need to split these. X minus 4 equals 2, or x minus 4 equals negative 2. Now I can add the 4 over. X equals 6, or x equals 2. So that has 2 totally different answers there. You would be thoroughly sad if you had done the perfect square trinomial on this.
Yeah.
Because then you would have had to redo it back because you can't solve it otherwise.
Boil it.
Nope.
So always pay attention first to what it's asking you before you just start doing a problem so that you don't end up doing something that you're going to have to undo later. All right, problems 3, 7, 9, after you write these down, 11, 17, 23, 27, and 31.
I can't believe we did that.